Hi. For now, I hope that you're doing good and I hope that you're able to relax a bit. You know that there will be some upcoming examinations related to gas laws. So when you are to do problem solving of gas laws, of all the gas laws that's discussed in class, that might be a little challenging on you for some who may not be used to when used to too many stuffs, too many equations. So here I am right now trying to help you figure out how to make problem solving about gas laws easier in a way, and how to be able to analyze some problems when all types of problems related to all the gas laws equations will be given to you. So please don't forget that you interact with me in this live streaming by making sure that you are
Don't forget that you
commenting.
interact
Sorry,
with me in this
that you're commenting in the comments section below. Okay, so let me shift the attention to the the problems um, that I will be showing you in a while. Okay, wait. I am going to shift to my gases. Okay. I hope you can see that. For those who are viewing me right now, can you see my screen? Can you see my screen? Can you please have some comments so I would know if you can see my screen? Can you chat with me for those who are online right now? I can't see comments yet. Let me know if you can see this so I can proceed to the problems that I have in stored for you today. Okay? Can you see it? No comments yet. No one's chatting it. I won't proceed unless somebody tells me that you can see my screen. Can you see my live stream for Cam? Can you see my live stream for Cam screen? You can see it now. Thanks. Thanks, Rhoda and Jean. Thank you for the quick reply. Thank you. So may I proceed? Again, let me remind you. Let me remind you that if there are classmates of yours who need to know, or other STEM students who need to know that we are having a live stream so that you can be helped with the examination, please inform them now before we can talk of so many things. So tell them, broadcast it to them, share, and let them know that we're doing this. And before also I start, can you please get your notes, your periodic table, and your calculator so as to ready yourself with the problems that I'm going to give you. For today, I have prepared around 7 problems that I hope can enlighten you more and give you support for your studying later on. So, this is live stream for Cam. And this is the second time that Madam Narca is doing this. And I kind of learned something, a skill that I can learn so as to be able to live stream successfully to you. So I hope that you can learn from this, and forgive me if I may not be able to give you the best live stream for you, but you may hear some noise right now, construction noise, but I hope that doesn't disturb you that much and my voice will still prevail over the noise in the background. I hope that they're gonna stop in a while. so as not to disturb this live stream. So forgive me for that. I can't find a perfect place to do this. So just in this particular cubicle, but again, there's some people doing some works. Okay, I hope you understand that. Okay, let's start with problem number one. Or let's just have a recall first. Let's recall all the laws and the 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 equations that govern all these laws. Can I see my pen? Okay, so when we talk about Boyle's law, Charles's law, Gay-Lussac's law, and all of these laws, we've discussed this in class already. Wait, I have a pointer, but I can't. Wait, I can't see any pen yet. But let us just recall this. So when we talk about Boyle's law, the formula for Boyle's law is P1 V1 is equal to P2 V2 because pressure and volume are both inversely related to each other. When we talked about Charles and Gay-Lussac's law, it talks about volume and temperature. So we found out that these two variables are directly related. So therefore, the expression for Charles and Gay-Lussac's law is V1T2 is equal to V2T1. Same thing with Amonton's law. Amonton's law talks about pressure and temperature, in which case the two are still directly related to each other. So its equation becomes P1T2 is equal to P2T1. For combined gas law, combining the first three at constant amount of gas, so you'll get P1V1 T2 is equal to P2 V2 T1. Now, if you can't get what I verbally doing right now, please take note of whatever I am discussing so that we can you can catch up and look at your notes, your previous notes about this problem equation. And Avogadro's law talks about the relationship of volume and amount of gas. So volume and amount of gas, as we all know, it's directly related. So therefore, you will get V1N2 is equal to V2N1. And for ideal gas law, everybody, I think, can recall about ideal gas law. That's your PV is equal to nRT, and R should be memorized. That is 0.0821 liter atmosphere per mole Kelvin. And if we derive density from PV is equal to nRT, we would get the expression density is equal to pressure times molar mass over RT. While Dalton's law of partial pressure tells us that PT will just be determined through the summation of all the individual partial pressure of each gas. And in terms of mole fraction, Dalton's law, we can get the partial pressure of a certain gas by multiplying the mole fraction of that gas times the total pressure. And then for Graham's law of effusion, I hope you've studied that. We've agreed that you will study your Graham's law based from the previous videos I've made. Take note, for Graham's law, there are 3 videos you need to watch: the concepts, then problem solving part 1, and then problem solving part 2, in which I gave 3 different types of problems that can help you apply Graham's law of equation that says VA over VB is equal to the square root of molar mass of B over molar mass of A. So if you haven't watched that, please put that on your reminder that you need to be able to watch that first. Okay? Now, let me start with the first problem. Before I begin with this, please copy the problem in your notebook. And then after copying, please take note of your given. Take note of your given and tell me what gas law is the problem about. Leave a comment below, in this particular live stream. Leave your answer as a comment. give me the gas law that is applicable to this given problem. Are you copying? I hope you're copying. Okay, so far there are only three who are watching this. I hope the others would know about this. Okay, let me pause for a while first. Empty Hangout. Great. Um, wait. Okay. I can't pause it. Did you copy the problem already? Uh, wait, there's no there's no there is no pen I can use for this. Let me just pause it for now, and I'll figure out how I can write in this. I hope let's stop with problem number one, and I'll try to troubleshoot this as to the pen that I can use to signify this. Okay. Mhm. Did I stop already? Can you still hear me? Can you please chat with me if I'm still live? Am I still live? Am I still live? Can you please chat with me if I'm still live? Am I still live? Am I still live? Wait, am I still live? Hmm. Am I still live? Wait, okay. I'm still live. Wait, I kind of run out of some. Wait, I'm still live. Wait, I kind of run out of some. Okay, please have patience with me. I am still figuring out how I can end this. I'm using Hangout, by the way, so yeah. You can use this way.
3, 2, 1.
Okay, let me resume Hangout in Air. Okay, you heard that? I'll just